Hello, and welcome to this guide on cause and effect analysis. To make the content of this video more accessible, click the closed captions button or adjust the playback speed. In this video, we will examine the following topics: the definition of cause and effect analysis, common fallacies with this kind of analysis, the presence of uncertainty, and how to write a good causal thesis statement. Cause and effect analysis is the basis of all scientific reasoning. It begins the moment a child asks, why? Why did that happen? Why are things this way? Scientific reasoning is the outgrowth of these first questions. Causal reasoning answers such questions by explaining observed events as the effects of prior causes. Such reasoning moves backward in time, but causal reasoning can also move forward in time by predicting the likely effects of observed events. Causal reasoning depends on the idea of a necessary relation between two or more events. Events A and B are said to be causally related if event A, the cause, is necessary to explain event B, the effect. Errors in causal reasoning fail to establish this relationship. These errors are called fallacies. Let's look at three common causal fallacies. Our first fallacy is called the post hoc fallacy, short for the Latin expression post hoc ergo propter hoc, which means after this, therefore, because of this. This tempting fallacy mistakes sequence for causation. Medieval lore captures this fallacy with an amusing story about a rooster who always crows before the dawn and comes to believe that his crowing causes the sun to rise. The story illustrates that mere sequence is not proof of causation. Our next fallacy is called the correlation fallacy, which can be summarized as with this, therefore because of this. Many scientific studies are able to show correlations between events, but correlation is not yet causation, and further evidence is often needed to show causation. For instance, Alzheimer's disease and the use of aluminum cookware are correlated historically, but there is no accepted causal link between them. Our third fallacy is that of oversimplification. This fallacy occurs when an effect has multiple causes, but only one or two causes are accounted for in the analysis. It can also occur when a cause leads to multiple effects, but again, only one or two are accounted for. Oversimplification can be avoided by using a so-called fishbone diagram, like the one shown here, which can help the writer keep track of multiple parallel causes, or by reversing the diagram, multiple effects. Another way to avoid oversimplification is to create a causal chain using a flowchart to account for sequential causes. For example, a causal chain might begin with a flu epidemic, which causes staffing shortages at an airline, which leads to longer shifts and pilot fatigue, which leads to pilot error, which leads to the final effect, a plane crash. Causal chains can sometimes show surprising connections between causes and effects. But it is important to understand the aim of cause and effect analysis. While valid deductive reasoning promises a certain conclusion based on true premises, causal reasoning is inductive, meaning it seeks the most plausible interpretation of observed data. Some people speak casually of scientific certainty, but no such thing exists. Science properly understood reasons probabilistically. Because causal reasoning retains a degree of uncertainty, causal conclusions are often best thought of as statements of the author's position, rather than statements of fact. A position based on best evidence and sound reasoning, yes, but one still open to further discovery. For this reason, causal thesis statements are argumentative rather than factual, and good ones may seek to challenge rather than to confirm accepted belief. A thesis statement in a cause and effect paper may look something like this. Most people assume X, however, Y. For example, most people assume wolves and beavers don't get along. However, a recent study showed that reintroducing wolves to Yellowstone led to an increase in the number of beavers. Causal analysis provides an opportunity to do more than just state the obvious. In this video, we have looked at the definition of cause and effect analysis. We have looked at the fallacies that should be avoided. We have looked at the uncertainty of such analysis. And finally, we have looked at how to write an effective causal thesis statement. For more academic support resources, read this video's description. Thank you for watching. We hope to work with you soon.